If you're someone who scrolled through the wild world of Instagram and has looked at anything related to health or fitness, then there's a good chance that these guys have popped up on your explored page. Satvic Movement. They are apparently a health education platform that does not seem to shy away from making extravagant claims like radiation from household gadgets can give you cancer.
Every time you use your devices while they are charging, all the dirty radiation and the electricity flows through you and creates cancer inside your body.
Today we're going to look at if there's any truth behind that claim or not. Hi, my name's Pranav and you're watching Scienceisdope. For all those fortunate folks who didn't have a mini scare because of these guys and their content, let me introduce you to Satvic Movement. They are YouTube/Instagram influencers with over 4 million people following them, looking to them for health, fitness and lifestyle advice. They usually post content around yoga, detox and weight loss regimes, and although some of it is questionable content, at first glance they do look harmless. But then you get to posts like these that say radiation from mobile phones are cancerous, microwave ovens are not safe for you, and wired devices are safer than wireless devices. And boy, these things just instantly trigger my misinformation radar, and so here we are. Let's first figure out how exactly radiation works. Is it harmful? And if so, what can it do to your body? People have been skeptical about accepting something new throughout history. During the era when radio was a rage, headlines like these were common throughout the front page of newspapers. And this created an unnecessary fear in people's minds that radio waves can have an adverse effect on one's health. Microwave ovens and mobile phones also meant the same fate. Anyway, even if we keep these technologies aside, the history of fear goes way back. For instance, Socrates warned people against writing because he feared that it would create forgetfulness in the souls of learners because they would not use their memories. And when vaccines were first invented back in 1798 by Edward Jenner, people were afraid of deformities and religious repercussions from those vaccines. And there are several anti-vax notions that haunt us even today. If you want to learn more about anti-vax movements and claims around autism and COVID-19, you can check out my previous videos. The fact is, all these things that people were afraid of in the beginning turned out not to be dangerous. I'm not saying that everything that's new is safe or that it's dangerous. If they are dangerous or safe, they have to have convincing evidence showing that. The keyword here is convincing. Someone holding an instrument, showing you some numbers, or even saying that it's harmful isn't enough. They have to show you why it's harmful. And if they're not gonna answer that question, then I will. Is it harmful or not? And if so, why or why not? Let's start from the basics. Let's look at what this word radiation actually means. See this light bulb? Let me turn this on. Okay, so if I keep my hand here, I can see a shadow on the wall. Keep it here, I can block it from your view. Basically, the light is coming out from this bulb and going in all the different directions. If you imagine a sphere around this bulb and the light source is at its center, then the light is coming out of that sphere along the radius in all the different directions. In other words, radially outward, and that's where the term comes from, radiation. In fact, you can technically use this anytime there's a source radiating something outward, like a sprinkler radiating water, or you might go to the doctor and say there's a pain radiating from this point of my shoulder. But generally, we tend not to use the term radiation in those contexts. We reserve the term radiation to mean electromagnetic radiations, and light is a form of electromagnetic radiation. But why they called electromagnetic? Because they made up of electric and magnetic fields, or EMFs, going up and down in a wave format. And these waves have a frequency that's simply the count of how many times the wave is going up and down in a second, And this frequency is what we use to classify different kinds of electromagnetic radiations. And this is called the EM spectrum. And radiations of all these different frequencies exist, but we can't see them because our eyes are sensitive only to this tiny band of frequencies, and we call that visible light. Radiation of different frequencies are used for all kinds of things. Mobile phones, Wi-Fi, Bluetooth, X-rays, microwave ovens, etc. And they all use light of all these different frequencies that we can't see. Here, I'll give you an example. Take any kind of remote control and you'll see that there's a bulb at the end. And as a kid, I used to wonder what's the purpose of that light bulb if it doesn't give off any light. But today I know that even though my eyes can't see them, a camera can. Our mobile phones are just like this. They are constantly flashing light that we can't see. And when we refer to radiation from phones, this is what we mean. But to understand if that radiation is harmful, we have to understand the energy of this light, of these waves. And for this, we come back again to the frequency of these waves. It tells you how much energy the waves have by this equation, E equals h nu. As the frequency increases, the energy also increases. And so here in this diagram, on the left we have all these higher energy radiations, and on the right we have all the lower energy radiations. Now what does it mean when we say a radiation has higher energy? Let's look at this experiment by the Action Lab. Link in the description. He's got a piece of zinc metal connected to an electroscope. That's just a device that indicates when there's charge on something. He puts some negative charges on the piece of zinc. The electroscope deflects from its normal position, indicating that there's charge, and watch what he does next. He shines light on it in an attempt to remove that charge, but no matter how bright he makes it, it does not remove the charge. But the moment he uses a not so bright ultraviolet light, watch what happens. The charge slowly gets released from the light. What you're watching is called the photoelectric effect, and his work in understanding this behavior of light is what won Albert Einstein his Nobel Prize. So what exactly happens here? Inside the atoms of the material, there are electrons which are negative charge carriers, and the photons or particles of light are hitting them. The electrons get the energy from the photons hitting them and can jump out of the atom only if the photons have that minimum energy required to make the electron jump out, or the minimum frequency required to do that. And that's why in this case, only ultraviolet light, which had that minimum frequency, was able to do that to the electrons, not the visible light, no matter how bright the light was. The photoelectric effect is something that's seen in metals, but if you have radiation of high enough energy, high enough frequency, then they can cause electrons to eject out of atoms of carbon that our bodies are made up of. And this is where radiation can be harmful. A bright ball of light. That's the last thing many people saw on the morning of 6th August 1945 in the city of Hiroshima, Japan. The United States had just dropped the most destructive bomb ever used in a war over the city. The bomb had nuclear material, the uncontrolled reaction of which released unimaginable amounts of energy. More than 90,000 people lost their lives instantly, and over the next few days, many thousands more would succumb to their injuries, and something that accompanies such nuclear bombs: radiation exposure. A tragic day for humanity, but it was also a tragic day for the word radiation, because it was after this event that the word radiation started getting this negative connotation. Radiation can kill people, radiation can cause cancer. People started becoming cautious of this word, but they were missing one little detail. The nucleus of uranium splits into fragments, and this is the chain reaction that occurred when that bomb exploded over Hiroshima that day. This sort of a reaction is usually accompanied by the production of gamma rays. Even the end products of this reaction continue to give off gamma rays. In other words, they were radioactive, and it's these gamma rays that were dangerous. Why? Let's look at the photoelectric effect experiment I showed you earlier. When an atom loses an electron, it gets charged and becomes an ion. And the photon which made that atom an ion is called the ionizing photon. And it was able to do so because it was of high enough frequency and therefore high enough energy. Since all chemical bonds are basically an interaction between charges in atoms, when an atom becomes a charged ion, its chemical nature, that is, its capacity to form bonds with other atoms and ions, changes. And when this happens to atoms inside our bodies in our DNA, it can lead to diseases like cancer. This is exactly what happened to those people in Hiroshima. The gamma rays emitted by the nuclear material in the bomb were such powerful ionizing radiations that humans, being in their presence, nearly destroyed them. Now we've learned that ionizing radiations can be harmful to us. So where do they lie in the spectrum? On this left end of the spectrum, higher frequency than visible light. And if it has lower frequency than visible light, then it cannot ionize any atom, not only in our bodies, but any atom in the world. So then what type of radiations are emitted by our mobile phones? Microwaves. Even 5G radiation lies in the microwave part of the spectrum. 5G spectrum is around 3.5 GHz and 4G is around 2 GHz. In fact, all wireless technologies that we use like Wi-Fi, Bluetooth, radio, they all use non-ionizing radiations. They cannot ionize the atoms of our bodies and cause cancer that way. I'll give you something else to think about. This light that's shining on my face right now, those radiations are higher frequency than any of the wireless technologies that we use. Visible light has a frequency that's 1 lakh or 100,000 times higher than 5G radiations. Yet I'm not afraid of this light on my face possibly giving me cancer. Am I? No. Nobody is. You have to go into the UV part of the spectrum to find radiations that have the minimum amount of energy to cause cancer. And that too, it can't easily cause cancer. On minimal exposure, it only causes sunburns. You need prolonged exposure for it to cause cancer. I might have convinced some of you, but for those of you that are still skeptical, you might think, hey, microwave ovens can heat up our food, so why can't they heat up our body tissues? Don't mobile phones also produce microwave radiation, so can't they cause the same kind of harm? For example, you might have noticed how your phone gets really hot when you make calls. So isn't that because of radiation, and isn't that harmful? Okay, let's look at all these one by one. First of all, a microwave has 1,000 times the power of a mobile phone. Comparing the two would be like comparing stadium floodlights with the light in your house. Second, it's not the radiations from the microwave that heat up the food. What they do is they make the molecules of water in the food vibrate faster. This vibration of molecules causes friction, and that's what causes the food to heat up. That's why when you heat food in a microwave, it's hotter on the inside, unlike when you cook something over a stove, where it's hotter on the outside. Okay, Pranav, fine, no water, no heating. But our body contains water, right? So can't these radiations heat up our body? Yeah, sure, if you cut up some part of the body so that it fits in the microwave and put it in the microwave and close the door. Yeah, sure, you can heat it up. But you would never do that unless you're some serial killer. Plus, these microwaves are designed to be safe. One, it doesn't work unless you close the door. And two, there's a grill, a mesh that prevents these radiations from even coming out. How does that work? This is an idea from physics called a Faraday cage. I'm not gonna go into it in detail here, but you can check it out yourself. But basically, an electric field cannot exist inside a metal. So this means no electromagnetic radiation can pass through a Faraday cage like this. So unless your microwave is faulty or broken, you're safe from these radiations. There are movements about a microwave like it destroys the nutrition in food. I'm not gonna tackle them in this video, maybe a future video. Now let's come to mobile phones. If your phone heats up when you make a call or when you're playing some games on your phone, that's because those are processes that draw a large amount of current from the battery. And whenever current flows, that heats up the battery and other circuitry. And that heat is what you can feel on your hand. I can assure you that the radiation from your phone cannot significantly heat up body tissue. I can also assure you that by this mechanism of ionization, mobile phones cannot cause cancer. Okay, Pranav, what if they cause cancer by some other mechanism? And why do governments prescribe these maximum allowed radiation levels from mobile phones? That's for our safety, right? And what about this? WHO describes mobile phones as possibly carcinogenic. How do you explain that? Okay, let's go one by one. WHO in 2014 classified radiation from mobile phones as possibly carcinogenic to humans. And a lot of pages that focus on radiation fearmongering, if they cite sources at all, use this as a source to say that mobile phones cause cancer. So let's talk about this WHO declaration. This happened in the wake of a study from Sweden that found links between mobile phone radiations and brain cancer, and another study on rats that developed cancer when exposed to radiations. Okay, let's talk about that first research paper, which found a relative increase in risk of brain cancer among cell phone users. This was a case control study, and the results from such studies cannot be accepted with certainty because of certain errors and biases that tend to creep in because of the way in which the study is conducted. Here are some of the things that made the study prone to error. 1. Self-entry of data. The participants of that particular study and most such studies are asked to enter details of their mobile phone usage and their health status by themselves without any expert supervision, and this makes the data entered by them kind of unreliable and easily biased. For example, people might give more importance to recent health events that they can recall, and that makes the data biased. 2. Small duration. If you look at the study, you'll notice that it was conducted over just 2 years, which is not long enough time period to study the occurrence of brain cancer. A study that was conducted over a decade or two would be more reliable if it made such conclusions. 3. Small sample size. Brain tumor or cancer is something quite rare and occurs in less than 1% of the population during their lifetime. So finding a large enough sample size to make your research results reliable can be quite tricky. You can see this study covers only a small sample of like a few thousand people, which is not enough. We cannot make broad conclusions from the study. All we can do is say that, hey, there may be something here, we need a more thorough investigation. If we want to confidently conclude that mobile phone usage do indeed cause brain cancer, then we need a different kind of study. A randomized control trial. I've spoken about how that's done over on this video. Find a group of people that don't use mobile phones, give half of them phones and the other half nothing, and monitor their health status over 10 to 15 years. You can see how this would be completely impractical given that pretty much all of us have a mobile phone and given the extreme rarity of brain cancer. Another thing that you could do is get the mobile phone usage data of a large sample of people and get their health records from hospitals or insurance companies and see if there is a relationship between the two. That data would be much more reliable. Wait, you know what? Such a study was done in Denmark, and you know what it found? No increased risk of brain cancer. This study was conducted over the entire population of Denmark, and it found no increased risk of brain cancer. Here's another study of 1 million people in the UK, and again it found no increased risk of brain cancer. There's a simpler way to settle this debate. We know that practically everyone has a mobile phone. So over the past 2 decades, mobile phone usage has gone way up. So if they do cause cancer, then the cancer rates across the world should also go up, right? Is there a study that looked at this? Yes, there is. A study published in the US in 2012 looked at exactly this. It looked at mobile phone adoption and cancer rates from 1997 to 2008. And you know what they found? The cancer rates remained unchanged over those 10 years. They found no increased risk of brain cancer associated with mobile phone usage. So now the question is, why did the WHO say that? Let's look at that WHO page again. It talks about a formal assessment that will be conducted in 2016, but the page itself has not been updated since 2014. That's pretty irresponsible of them if you ask me. But at least we know that we should not go by what's written on this page. That's not the latest information. What about the other paper I was talking about? The study where rats got cancer when exposed to radiation. Okay, unless you're a male rat watching this video, you need not worry because the scientists from the study themselves emphasize that these findings don't apply to humans. Here's the problem with statements like these. One piece of evidence is enough to say that this is true. But there is no one piece of evidence that can say it's false. We have to look at a case where it could be true and make sure it isn't true, just like all these studies have done. And technically, we have to keep doing it forever because there could be some scenario, some mechanism, some special case that we haven't thought of yet where it could be true. But so far, no such research has come. And because we can't say for sure that radiation cannot cause cancer, governments have set standards for maximum allowed exposure levels that these gadgets can have. And these exposure levels are tested to make sure they're safe. These are called SAR rating, stands for Standard Absorption Rate. I'm gonna call them SAR for ease throughout this video. Every wireless device has to get a SAR rating before it can go into the market. So if you're using a gadget that has a SAR rating, which is every major mobile company out in the market, then know that you're safe. Now, despite all this assurance that wireless gadgets are safe, we have channels like Satvic Movement spreading fear among their viewers. Let's see what they say. Satvic Movement promotes ideas like radiation from your phones and laptops can cause cancer, EMFs from gadgets can shorten your lifespan, a child's body can absorb up to 60% more radiation per pound of body weight than an adult's, and radiation increases your risk of brain cancer by 3%. I tried to look for the source of such highly specific information, but oh wait! They don't cite any sources. But unlike them, I'm gonna cite all my sources in the description for you guys to check out later. Okay, Pranav, they might not have cited sources, but they give us demos where they show that microwaves can give off a lot of radiation. Just look at this post. This doesn't even make sense. 400 of what? Where is the unit? 400 volts, 400 kilometers, 400 Italis? They don't even mention. You can only see the unit clearly over here in this frame of the video they posted. And the instrument you're using, it's called an EMF meter. It supposedly comes in handy when measuring EMF pollution or when ghost hunting, because apparently ghosts give off EMFs. So you can see that there is a clear overlap between the kind of people that not only believe in but hunt ghosts and the kind of people that are involved in 5G fearmongering. Before I digress, let's look at this value 400 volts per meter. I know how they managed to get that reading on the instrument because according to scientific literature, if you're standing even 5 centimeters away from the oven, the reading can only go up to some 55 volts per meter. So unless your microwave is broken or is leaking radiation somehow, you can never get such high values. And in this other post, which is apparently a demonstration, one person gets a shock from the other person who is using a laptop while charging. Okay, getting a slight shock when you touch the metal surface of a laptop while it's charging is a common occurrence. It's called a tingle current and it can lead to a low-level harmless electric shock caused by like residual charges on the body of the laptop, particularly those that are charging and they only have two-pronged chargers. This happens due to grounding issues and has nothing to do with radiations. Radiations cannot give you an electric shock. And they do all these charades to intimidate people and get a reaction like, oh my god, 300, such a high value. Okay, you know what else creates such high values, or maybe even higher than that? The Earth. Yep, depending on where you are on the planet, you could be experiencing fields, electric fields of 100 to 300 volts per meter between your head and your toes. Even if you're walking somewhere in the middle of nowhere in a park, away from all sorts of radiation, gadgets, etc. So these values clearly aren't a proof that these radiations are dangerous. They have to resort to gimmicks like these because they can't try and convince you that or show convincing evidence why it is dangerous. And the things they do look like poorly done magic tricks to deceive their audience. For example, did you notice how the camera is very far away from the screen of the instrument in this shot, and then they have to cut and before they zoom in and show a close-up shot of the instrument? I have no idea what happened between those two shots, and neither do you. And I wouldn't be surprised if these values were faked for the camera. And this is how they validate what they're saying, by having conversations with an expert. There's a live stream on their Instagram page with Nicholas Pino, hope I'm saying that right, who wrote a book on the dangers of EMFs. The book has some questionable reviews, so I had to find out more about them. Not only was I unable to find relevant qualifications, but one look at his social media and he seems to be just another 5G fear-mongering person. He's got ridiculous claims like putting a phone on airplane mode can make you feel years younger and make unexplained symptoms vanish, etc. Again, with little to no scientific evidence. If you look at their live stream with Mr. Nicholas, then you'll notice that they conveniently skipped the part where you introduce your guest and tell people about their qualifications and credentials and whatnot. Look, I'm not sitting here and saying that you have to be a scientist or have a PhD for you to be an expert. But if you are one, then show us convincing evidence of whatever you're claiming. We live in an age where we have more information at our fingertips than we ever had before. So why is this so hard for you? Like I always say on this channel, extraordinary claims require extraordinary evidence. Posting opinions as fact or cherry-picking research and data to create unnecessary fear among people, not cool guys, not cool. Social media, like any other industry, thrives on what it wants, and it wants your attention. If you tell people that there is something to fear over here, then people will want to see it. And so this kind of fear-mongering tends to spread fast on social media. This is where you as the content creator have the responsibility to first understand what you're talking about and not spread fear among your viewers. And that too on this terribly researched wrong information. And if you are consumers of such content, then it is also your responsibility to be better aware and better equipped to differentiate fact from fiction. And my whole mission is to equip people to be able to do exactly that. If you like what I do, subscribe. And I'll see you in the next one. Till then, remember, science is dope.